Okay, today we're going to write quadratic functions from given data. So go ahead and take your notes out and remember to pause the video if I'm moving too fast, or you can rewind the video if needed to listen to something again. You can also download chapter 4 in your Chromebooks and look at section 10, and we have some more examples there as well. Okay, today as we write quadratic functions, we have to remember the forms of the quadratic functions we looked at. So let's recall the intercept form. It looked like this. F of x is equal to a times x minus p times x minus q. Remember, p and q are your intercepts, your zeros. To use this form, we need to have the value for a, the value for p, and the value for q. So as we look at the data they give us, whether it's a graph or tables, we have to come up with these 3 points, whether they're given to us directly or we can solve for them indirectly. The next form we looked at was the vertex form. F of x is equal to a times x minus h squared plus k, where h and k are a vertex, and a was the value that told us if it opened up or down, and also decided how wide or thin the parabola was going to be. To use this form, we need the a, h, and k. And the last form we looked at was standard form. F of x is equal to ax squared plus bx plus c, where we knew that c was your y-intercept. And to use this form, we need a, b, and c. So as we start our example, we just have to remember whatever they give us, we have to be able to come up with the a, b's, and c's, or the a, h, and k's, or the p's and the q's. So let's take a look at an example and see how we're going to do this. Okay, we're going to write the quadratic function, and we're given this graph. We know it goes to the point -4, -1, and has a vertex of -2 and -3. So go ahead and copy that down. If you need to, pause the video. Okay, given this data, here's what we know. We know that we have a point, and we'll call this point x and y. So we're given an x and y, just a point on the graph. And we're also given our vertex, and we'll call him h and k. Identifying these will help us figure out which form of the quadratic we're going to use. So if we look at the form, knowing we have h and k and an x and y, standard form really isn't going to work for us. We don't have a y-intercept. We could attempt to solve for b or a, but I think that's going to get too complicated. So let's jump back and try to use another form before we decide to go this route. We could use vertex form. Vertex form requires an h and k. We do have h and k, but we'd have to solve for a. And that might be doable given that we have an x and a y. Let's look at intercept form. Maybe that's a better one. We need the intercepts. We do not have the intercepts, nor do we have an a. So I'm thinking intercept form is not going to work for us. So I think our best bet would be the vertex form, judging by what they've given us. We have the h, we have the k, but we need to go solve for the a. So vertex form is my choice. Okay, let's try it. Using vertex form, so I'm simply going to write the problem out, or formula out, y is equal to, or f of x, a times x minus h squared plus k. Then we're going to simplify or substitute, sorry, not simplify, substitute, not simplifying yet, substitute what we know. We know we have an h, and the h is a -2, so I'm going to go minus a -2 plus our k, which is 3. And a little simplification, we get y is equal to a times x plus 2 squared plus 3. And we need to come up with a. So we're going to have to use this point x, y. Well, I have an x and I have a y, and if I substitute those values in here, I'm left with one variable a, and I can just solve it. It'll become a linear equation at that point. So let's go ahead and do that. Let's substitute in the y, which is -1. is equal to a times our x, which is negative 4, and with some simplification here, so I'm going to go over and do some side work. That's negative 4 plus 2 equals negative 2, and then he's squared, so I'm going to square him. That leaves me positive 4. So this negative 4 plus 2 squared is simply positive 4. So substituting that back in, negative 1 times a is equal to positive 4 plus 3, or negative 1 is 4a plus 3. Now looking at, after our simplification and substitution, we just have a two-step linear equation. Solve for a. And keep in mind what we're doing. We're trying to find the value of a so we can plug it in and write our equation. So let's change color back to red to solve. Minus 3 minus 3, negative 4 is equal to 4a. And that guy goes to 0, which implies a by division is negative 1. We now have our a. We have our h equaling, let's go back up here and check, negative 2 that we've gotten from our graph. And we have our k, which is positive 3. So using what they've given us directly and using some information they gave us, we solved for a, so a was given to us indirectly. We can now write our equation. Our equation is y is equal to a, which is negative 1, times x minus h. Well, h is negative, minus a negative again is plus, squared, plus k. We now have the quadratic function that gives us the following graph. Okay, I hope that helps a little bit. So if you have any questions, jot them down and we'll take care of them in class.